All right, atomic trends. This is the first trend that we are learning about, atomic radius. So this is a standard, so we're talking about this first one. I can explain the trend for atomic radius using the periodic table and just compare the atomic radius of other elements. So you should be able to do that by the end of this. All right, here is a picture. This actually literally illustrates atomic radius, so we're going to keep referring back to it. You should notice that the first thing you should notice as you're looking at it is as you go down, they get bigger. And as you go from left to right, they get smaller. Okay? So, let's talk about what they are. Atomic radius of a chemical element is the measurement of the size of the atoms, usually referring to the distance from the center to the edge of the cloud. Okay, and we can already see what is the trend. As you go down, the atomic radius goes up. So as you go down, the atomic radius increases. As you go from left to right, the atomic radius decreases. Okay, that's the trend. You just have to memorize that. As you go down, the radius increases. As you go from left to right, it decreases. Let's talk about why. So as you go down, what's happening as you're going down? Well, think of it this way. As you go down, remember each one of these periods, each period represents an energy level. Okay? So why do they get bigger as they go down? Because every time you go down a row, down a period, you're adding another energy level, which increases the size of the atom. So if you have your nucleus, you have the first energy level, you're there. As soon as you add another layer, you're now bigger. Think of it as putting on layers of coats. The more, every time you go down a row on the periodic table, you're adding on another layer, another coat. So you're getting bigger and bigger and bigger because you have more and more layers the further down the table you get. Okay? But as you go across, what's the trend? As you're going across the period, you get a different trend. You're going from bigger to smaller. Well, why? Well, let's think about what is happening as you go from left to right. What's changing? Okay, why are these organized? These are organized by atomic number. Okay, what's atomic number? Atomic number is the number of protons. So every time you go over a column, every number you're going over, you're adding more protons, right? So the number of protons increases as you go across, therefore increasing the attraction between the nucleus and the electrons. So remember, where is your nucleus? The nucleus is right here, right? You have the center nucleus. Every time, let me make this bigger. Every time you add, so if we have the hydrogen, right? You have a nucleus got a proton in it, and around it you have an electron, right? So there's an attraction. The electrons, which are negative, are being attracted to the protons in the nucleus. Well, when you go to helium, you now have 2 protons, and yeah, you have 2 electrons, but you still have all of that the positive protons. It's concentrated in the center. So that means this is able to pull twice as hard on that electron. So it's basically like when you suck in your chest, like you get cold, you kind of, or like you suck in a blue, like you're pulling, and pulls the electrons closer. Okay. So as you go from left to right, you have more and more protons, which are pulling those electrons closer and closer. So the atoms get much, much smaller. Okay, which is what you see. And then remember, it resets when you go down, because now you go down. Yeah, it got smaller. But then you go to the next row, and now you have another layer on top, so you've gotten bigger. But then as you add more protons, they start pulling those electrons closer and closer, and you get smaller and smaller again. So, repeat the trend. As you go down the table, the atomic radius increases. As you go from left to right, the atomic radius decreases. And all of this is the top to bottom is due to the number of layers that you have. Left to right is due to the number of protons pulling on the electrons.